Hey guys, welcome back to Outpost 95. Today we're going to talk about intersection as it relates to land navigation, specifically with a map and compass. What intersection allows us to do is find an unknown location from a known location, preferably if you've got two or more places, but this can be done with just one location as well. What this is really helpful for is if you're going to really get into map and compass work, is to learn how to do the intersection so that you can more readily learn how to do a resection. Resection is going to help you take a couple of known locations and find the unknown location, which would be yourself, or to confirm that you're in the actual location you think you're at. It's to help you from getting lost. So this is the building block of the math. I know it's kind of boring, but if you want to get into this stuff, this is super important to learn. We're going to be building off the plotting of the points and the declination that we talked about in the last couple land navigation videos. Thanks for joining us. Hope you learned something today. Alright guys, we're going to try this on our Nat Geo map that we prepped up before. The tools that you're going to need will be a grid square reader, a pencil, mechanical works the best. Remembering that our Nat Geo maps don't have the correct grid for the 1 to 25 or 1 to 50,000. We made our own, as in the other videos, going off the scale. And then I've got some notes with our basic information on it here. Now I've got a marker, hopefully to make everything a little bit more readable. If you're doing real map work, don't ever bring a marker out, because you don't want to put that permanent mark on your map. Okay, in this scenario here, we're trying to work on intersection, which means we've got two known locations and we're trying to find a third unknown location. Well, let's say that we've got me set up on this little hill here, and we've got Dave set up on this little hill here, these two locations. And we see something that occurs down in here. It could be Dave shot an elk, it ran, fell in the field, and we need to know exactly where it is so that when we climb off the hill, we can just go straight there. It could be fire's happening. We need to report that up so that the firefighters know where to get to. Any number of hypothetical situations here. All right, my location here, I've already plotted it. I use the UTM, Universal Transverse Mercator system here. That's because that's what these National Geographic maps are. This exact same formula will work out with Military Grid Reference System, the MGRS, utilizing these same 10 numbers here. It's a 10-digit grid. Remembering this is your grid square, your 51 right or east, and your 88 north is this grid square here. Plot it out just like we've seen before. And then we've got Dave's information here. His location, same thing. He's in grid square 53, 88, 53, 88. Now, we've seen something occur down here. We pulled out our compass, and I shot a magnetic azimuth of 103 degrees, magnetic or compass. So you record that information, and I range this at about 1145 meters. You don't need that. The important part is getting the compass reading, the compass azimuth. We'll go over this in a future video on how to use the compass here. Dave did the exact same thing, and he got his magnetic azimuth at 221 degrees. And he did a range as well of about 610. So now we're going to take these numbers and convert them here. Got some basic notes. Remembering that North Idaho's got an east declination corrected of about 14 degrees as of April, was when I did this last correction here. We're going to take my info, and when you're doing this math in the field, try to keep everything separated out when you make your notes so that you'll understand what you wrote down. I've got 103 degrees magnetic. I always try to record what it is so that I don't forget. Again, in the field, it's super easy to mess this up. And I need to get a grid or map reading. So I got my magnetic is my compass, and we need to get it back onto this map. So to go from compass to map, or magnetic to grid, I'm going to add 14 degrees. Plus 14. And that's grid. All right. Let's take Dave's information. He's got 121 degrees magnetic. Same thing. We need to take this to grid. Magnetic to grid. We're going to add 14. We got a 5, 3, 2, grid. I'm going to circle those because these are the numbers I need to work with. I'm going to get rid of these notes. Right now I don't need that. Okay. You're going to take your protractor. Get you a better look at your protractor here. You can see at the top it starts with 0, and that 0 becomes 360 again. And it goes all the way around. East is going to be 90. South is going to be 180. 270. And then 360 or 0. So we got our math. My location. Remembering that this one is me. I need to go on the map 117 degrees. 117 degree grid or map. I'm going to take the center hole, my protractor, and I'm going to center that over my location. These grid lines on the map need to be in line with north and south as much as possible. Small errors on the map can mean big errors in our map math. So we're going to center that up, and we are going to try and make these lines run parallel. And then you can use, what I find easiest to learn with is cardstock or index cards. In the field, I'll usually take a piece of string, a real fine string, run it through the hole, put a knot in there, and then I can use that for quick measurements. But here on the tabletop, it works much better to start, in my opinion, with cardstock. So the center, again on my location, and then we need to find that 117 degrees. So we've got 115, 2 more lines is going to be 117. I'm going to draw a faint line here. You want to make light marks on your map because at some point you're going to have to erase these off. Making sure that everything's still lined up. Okay, I'm going to make a line here. You'll do the same thing from Dave's location. It's a 235-degree grid. So remembering he's over here. Still making sure that all of our lines are parallel. Getting the edge of this cardstock right on his location. .235. Okay. Now we've drawn two lines, and they've intersected here. If you had multiple locations, you could continue doing the same thing, and then where the center of those lines intersecting would be the location. You would want to have these as close to a 90-degree angle as possible because you're going to have a more precise location that you can pick up. As you can see, any errors in your measurements, shooting your azimuth, doing your math, the way you align your protractor can make a big difference in your location here. You'd go back down now with your grid square reader and read this location. So let's find the grid square we're in. We're in 52 East. And we're in 87 North. Now you're at 6, just a smidge past 6.5, right? So we'll say 655 for an easting, and then a northing, again, just past 6, not quite to 6.5, say 645. You could add back in all the UTM stuff if you have to do the full plug-in. I remember we went over that information in another video if you really want to go deep into that. So how could you double check this work? Well, you could say, let's find Dave's information here again. He thought the range was about 610 meters. Let's check our work. Because this is 1,000 meters. This should be just past the 6 line, the intersection. So there's 6, just a smidgen past is where we found him located. On my side, we see that it's gone past this same length, or the length of 1 kilometer. Let's take a piece of cardstock or scrap piece of paper with a sharp corner. There we go. For my location, the little dot to the intersection of these two lines. We'll make a mark. We'll go down here to our map scale because we've gone over a kilometer. We've got 1 kilometer here, and then we've got another kilometer here marked out in about 100-meter increments. So there's 1, and then another 100, and then this looks like it's just past the halfway point. So we'd have a 1,155-ish meters. Let's see what I had down here when I did the original math. Looks like we're at least 10 meters off, but you're still going to be very close to the general location. All right, guys, thanks for sticking through with that. That's a lot of math. Unfortunately, map work can entail a lot of math if you're trying to be super precise. If this doesn't make any sense, just let me know in the comments. Also, if you want me to put up something on the website, maybe like a homework type assignment where you can practice this, let me know and I can work on doing that. It's going to be a lot of practice that will make this start to click in your head. Better to practice it on the tabletop as opposed to trying to do it in the field. You have a flat surface, you're hot and sweaty, you're trying to figure out what you're looking at. So it's a lot better to practice a lot of this on the tabletop if you really want to get good at it. Again, thanks for watching. Please like and subscribe. God bless.